Is your job search stuck? Maybe you're not getting any interviews with employers. Or maybe you are, but no job offers. Or you may be new and not even know where to start. This is Charles Max Wood, and I'm releasing a new course ebook on how to find a job as a software developer. The course walks you through the process of finding the types of companies you want to work for, getting their attention, and putting your best foot forward as the candidate they want. I've coached dozens of developers in looking for jobs and have been able to help several people find jobs within 2 weeks to 2 months. So whether you're new to development, can't find a great job that fits what you want, or are looking for remote work from an area without a strong tech community, I can help. Go to getacoderjob.com and sign up today. Hey everybody, and welcome to another episode of Adventures in Angular. This is actually a recording that we did a few years ago with Brendan Eich. He talks about the origins of JavaScript, and we did this for JavaScript Jabber. But I thought that you folks on Adventures in Angular would be interested in it. So I'm going to go ahead and let the recording switch over. And go out and check out some of the stuff that I've got going on these days with getacoderjob.com. If you're looking for a job, go check out codebadge.org if you are interested in some of the guided learning and staying current stuff that we're doing there. And always devchat.tv, swag.devchat.tv if you want a shirt or a pillow, or we've got all kinds of stuff on there, a mug with the Adventures in Angular stuff on it. Anyway, I'll go ahead and have the editor switch us over now. Hey everybody, and welcome to episode 124 of the JavaScript Jabber Show. This week on our panel we have Joe Eames.
Hey everyone.
Aaron Frost.
Hello.
AJ O'Neill.
Yo, yo, yo. Coming at you live from Boston.
Jamison Dance.
Hey friends.
Tim Caswell.
Hello.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, Brendan Eich.
Hello.
Do you want to introduce yourself real quick for us, Brendan?
Hi, I perpetrated JavaScript in 1995, and I've been making up for it ever since.
Awesome. Still perpetuating the lie. That's awesome.
Awesome. So we brought you on to talk about kind of where JavaScript came from. I'm kind of curious to know, just for my own edification, I have clients and others who ask me all the time, so you do Java? And so I want to know why it was called JavaScript for one. But yeah, maybe you can kind of give us a little bit of backstory on JavaScript.
Yeah, that whole story I think is totally worth telling. Even though I'm sure you've told it 100 times, I know that I'd been doing JavaScript for quite a while before I finally heard the story of how JavaScript was created. So I'd love to hear it again.
Once upon a time.
Yeah, you guys should cut me off because it'll go on and on. So the thing you have to know about Netscape is it was a Jim Clark, Marc Andreesen joint. So it was basically the union of NCSA Mosaic principles plus Lou Montulli from University of Kansas, who did the Lynx browser. I think that was spelled Lynx, which was a text-based browser. But everybody else at Netscape on the first floor was either from NCSA Mosaic or NCSA HTTPD. They were all at the National Center for Supercomputer Applications at my alma mater, University of Illinois at Urbana-Champaign. So Marc Andreesen recruited there heavily, and he paired up with Jim Clark, the founder of Silicon Graphics. So I was at Silicon Graphics out of grad school in 1985, which was great. It was pre-IPO. It was a hot valley company. This was back when you had technical Unix workstation companies building their own, basically CPUs, or building their own CPU boards around the Motorola 6820 or 6830 chip. And Sun and other companies had licensed the Stanford University Network Sun 1 architecture. And Andreas Bechtolsheim had given up his PhD to go found Sun with Bill Joy and others. It was a pretty awesome time in the Valley. It was before the PC. The PC was out. There was the 8888 or 8886. There was IBM PC, but it was kind of a joke. So for real industrial computing, you needed a workstation or a mini computer even. There were still mini computers around then. Digital Equipment Corporation was a thing then. And SGI was turned into a company from a Stanford research project Jim Clark was the professor of, which was building basically what became the GPU. They were building the graphics processing unit as a whole graphics board using VLSI technology. Carver Mead at Caltech had written the book. People could make lots of transistors on a single silicon die. and they could build something that was really good at doing lots of graphics operations in parallel. And that's where Silicon Graphics came from. But by the time the 90s came along, Clark was, I think, kind of squeezed out of management politics at SGI. He was kind of the chairman, but not otherwise empowered. He was annoyed. So he wanted to do something new, and I'm not sure exactly how, but he got introduced to Marc Andreesen at NCSA. There might have been some venture capitalists involved there. And they hit it off, and they thought about doing something which became Netscape. And the weirdest thing was they went through various ideas. I only know of one that I heard about, they were serious about for a few days or weeks, which was, let's build Nintendo 64 software for modem-connected N64 boxes. And that wasn't looking too good after a few days, so they decided, no, let's go make the internet commercially viable. Let's kill Mosaic by making a Mosaic killer browser, which will be the killer app, which will actually have security for commercial e-commerce. And that's what they did. That was Netscape 1.1.1. They did things like SSL. They did kill Mosaic. They took all its market share. They originally were called MCOM, not Netscape, Mosaic Communications. And I think NCSA's lawyers came calling, and there was a rapid rename to Netscape. And of course, when they were founded, because they had Clark as a co-founder, he drew from Silicon Graphics early talent. So he drew Tom Paquin to manage engineering, and Kipp Hickman, who was my senior partner when I joined SGI out of grad school as a kernel hacker. And Kipp called me up while I was at MicroUnity Systems Engineering, which is a crazy company I'll tell you about later. And Kipp said, you want to come join us? It'll be fun. We're going to do a, Mosaic killer. And I said, I've still got some things to finish at MicroUnity. So I stayed a year like an idiot and missed out being on the first floor. So I joined in April 1995, a year into Netscape. When I came on board, Netscape 1.1 was heading toward release. And because of some weird financial shenanigans, they couldn't hire me into the group they wanted to hire me into. They had tempted me there. All these Silicon Graphics people I knew, like Kipp and John Gianandrea, they said, come and do Scheme in the browser. We need a programming language in the browser. Come and do Scheme. And Scheme was like a language that I only learned through like book learning, through Sussman and Steele's SICP, famous book, Structure and Interpretation of Computer Programs.
Did you like it though? Like, did you go, I like Scheme, I'll go do that?
Yeah, I said, big idiot me. I said, I like Scheme, I'll go do that. And of course, when I got there, the answer was, oh, well, wait, we're doing a deal with Sun, and they have something called Java, renamed from Oak, and we can't really let you do Scheme in the browser now. Plus, because of financial machinations I don't fully understand to this day, they hired me into the server team instead of the client team. So that was weird. And they ended up having me work on HTTP 1.1, or what we thought would be HTTP 1.1, way back then in April 1995. It had a lot in common with SPDY, and I was working with the McCool twins, Rob McCool and Mike McCool, who wrote NCSA HTTPD, which then forked into Apache, and they were fun to work with. And Ari Luotonen, who worked on the proxy server that Netscape productized. So for a month, I was screwing around with server-side stuff, but I was thinking about what to do to rescue the idea of a language for the browser, which wouldn't be Scheme. And so in May, I got switched to the client team finally. They got a headcount opened. I mean, even in a company of 150 people, they had headcount shortages and little games where people had to trade requisitions. So I ended up in May hitting ground running, really moving fast to create JavaScript. And it was codenamed Mocha. I wish I kept the diary, but I can tell you that it involved intense meetings with people like Marc Andreesen, not only at Netscape, but also at the Peninsula Creamery in Palo Alto, where they had like greasy burgers, fries, milkshakes. And at that point, Mark he was a big boy. We used to go there and get, he used to like Midwest food. He got a milkshake. He'd drink milk at work. There was a lot of junk calories being consumed. And Netscape also had something I was horrified to learn about that has become standard in the Valley, which is the sleeping room. So Tom Paquin, the engineering first floor manager, would take the sheets home every other day to get cleaned, which was good. Oh,
no.
But people were actually sleeping at work. And I was actually working around the clock because I realized in order to do what became JavaScript, I had to not only show that we could make a language work in the browser, I had to show that it wasn't redundant with respect to Java, which was the big deal with Sun that was brewing that led to this whole, we didn't really mean Scheme in the browser. We're doing something with Java. And the best I could pull off was, okay, so you have a language, Java, which is compiled. You have to learn what a compiler is. You have to run Java C. You have to write Java source code, which consists of classes, including a class with a main method, and you have to, a static method, and you have to compile that into bytecode. Right there, you've lost a lot of people who could write programs if they were written in an interpreted language. If they were in Microsoft stack at the time, they could use Visual Basic, and they wouldn't have to learn C++. But with Netscape and Sun cobbling up this deal, it was only Java, and it was this compiled language. It was kind of hard to use. It was typed. I'm not saying it was bad. It was just not for the casual, amateur, or beginner programmer.
Can I do a timeout and ask you a question?
Yeah, absolutely.
Did they come at you and say, Brendan, you have a hard stop in 10 days? Or did the 10 days thing just be like, I worked on it for 10 days and we had the initial prototype? Or did someone say to you, you got 10 days, otherwise this is dead? Or what's the 10 days thing?
So the thing that happened was, as you might gather from the story so far, they were trying to do a deal with Sun for Java. Sun thought Java should be the only language. They realized that it was too hard to use for amateurs and beginner programmers. They needed a language like Visual Basic and Microsoft Stack at the time. They needed JavaScript. And Marc Andreesen saw this clearly. So he and I were partnered up. That's why we would meet up at the Peninsula Creamery in secret, and we would plot our own destiny independent of whatever Sun was going to do with Java. And if we hadn't done that, there wouldn't be any easy-to-use language that you could embed right in the HTML. I remember Marc specifically said, no, you've got to be able to write the language, the source code, right in the HTML. You've got to be able to write it directly in there inside some kind of container tag. And so I went off and figured out how to make that work, which was horrendous because HTML, supposedly based on SGML, but its own sort of grammar, doesn't have the ability to embed like a less than operator in the middle of a tag unless you use a special content model for that element. And so I figured all that out. I made the script tag. I made it all work. But it was really a rush, not 10 days dead reckoned, but pretty damn quite fast in order to prove not only to Netscape but to Sun, and there were people inside Netscape who doubted, that there was a value in having a easy-to-use language you could embed directly in HTML, that amateurs could write, and that it could be done quickly enough that it could be shipped in the same release that Java was shipping in. And that release was Netscape 2.
So we could have wound up with Java. I love you even more now. That's all I have to say.
If it was only Java, the fact is Java bombed in the client. It took forever to die, but it's pretty much dead. It's like a source of malware. Chrome and Firefox blacklisted. It's gone.
So it wasn't called JavaScript. Was it called LiveScript? Is that?
Originally, Marc wanted to call it Mocha. Okay. And Marc actually, I'll tell you something I haven't told anybody. So Marc was actually not sure about Sun, so he thought, maybe we should do our own Java VM. So Kipp Hickman, my friend from early days at SGI, who was a senior kernel hacker when I hired, he started writing his own JVM. And this was before we had done a source license for Sun's Java virtual machine. So he started writing his own. He was trying to self-host the Java C compiler that Arthur Van Hoff wrote, which is written in Java. Very nice compiler written in Java. So if Kipp's VM could run it, we could conceivably do our own Netscape VM. It wouldn't be the Sun VM. It would run Java. And then we'd be independent of Sun. And Marc was so ambitious, he thought, okay, we'll have Kipp's JVM, we'll have your JavaScript VM. Now we need a graphics library, like for Canvas, for 2D and 3D graphics. Who can we get to do that? And I said, I work with somebody really smart at SGI. I'd like to hire him, but he's at MIT, being a grad student, and that's Andrew Myers, who's now a professor at Cornell. And so Marc's like, great, we'll hire him. We'll throw stock at him. So there was this grand plan, which never came to fruition, where we would have an entirely Netscape-created code base. It would be Kipp's Java VM, my JavaScript VM, and Andrew Myers, whom we never hired, graphics library. And so that lasted a few weeks. Also, when the rubber hit the road, what we had to ship was the JavaScript VM wedged into Netscape 2 in a way that actually embedded in HTML. You could have a script tag with inline content that was code, including the less than operator. You could then access like document.links sub-0 or document.forms sub-1 or document.forms.myform. And so I created this primitive version of the DOM that became known as the DOM level 0, all in those early days. And the worst part of it was that Netscape, the browser, which was written the previous year in 1994 in 6 months, as Jamie Zawinski has described, in order to kill Mosaic fast, was not designed to have a scripting language embedded into it. Because when you write JavaScript, you can extend the lifetime of a form. You can make a reference to document.form sub0, and suddenly you can keep that alive longer than the document. Well, what happens inside the old Netscape browser code was, as soon as you navigated away from that page, they freed all that memory. They just wiped it out, returned it to the C malloc heap, and if you kept pointers to it, you were in big trouble as far as vulnerability to crashes, security bugs, all sorts of things. So I was juggling with chainsaws trying to embed this arbitrary lifetime scripting language into a sort of mandatory lifetime, just so lifetime C code base. And that meant Netscape 2 was a nightmare of bugs. But in spite of that, to finish my statement before I run on too long, there were people using it even in the beta releases who were doing amazing demos. They would write forms inside tables, and they would write spreadsheets or calculators or various sort of form-based applications, even what we might call single-page applications today. They didn't have XHR, but they could hide a form element or a link that they would auto-submit or auto-click inside a hidden frame. And they made it all work. And I had to help them on workarounds because there were tons of bugs. And they were like, I have a demo next Monday, and I'm going to get my contract canceled if I can't demo. Can you help me? And I said, okay. I figured out a workaround, and I gave it to them, and they delivered it, and that helped JavaScript prosper.
So it sounds like, did you have kind of a vision of the potential of JavaScript? It seems like in the last 5 years, well, more than that. Maybe last 10 years, it started to come of age more and become more widely recognized as a platform for building mature applications. Did you always hope that would happen and think that would happen, or did it kind of happen as a surprise to you?
So, yeah, you're talking about Web 2.0 or the Ajax revolution?
Yeah. But, I mean, some of the stuff you described
5.
sounds like that happened in the early days, too.
It did. In 1995, early adopters, and I can't claim sole credit for this, like a guy named Bill Dortch, who's still online, he had a company called Idaho Design, like Idaho with an H in front. And he built all these essentially single-page applications using frames and frame sets, hidden forms or links. He even wrote like image generation using the XBM image format, which is the XBitmap format, which is an anti-compressed image format. It uses a subset of the C programming language, including the C preprocessor, to specify like a char array initializer containing the bits of the image. It's a crazy format. And he would generate this from JavaScript and load it using the right MIME type into image elements in the DOM, the primitive DOM level 0, and suddenly you get these like black and white drawings you could create. It's like an early canvas. So this was all like 95, 96, dodging lots of bugs. One of the bugs was funny. It was HTML tables, as you might know, can nest. And so Eric Bina, who I liked a lot, I really worked well with him. He was Marc Andreesen's coding partner. He was the real programmer on NCSA Mosaic, and then he joined Netscape. His layout engine was very brute force about tables. It would basically do a table layout by laying out its contents, measuring the widths that you got from, the heights that you got from the widths, measuring how much space it needed, and then laying out the parent table. And so if you nest tables, like n levels deep, you get 2 to the n passes to do all this sort of measurement. And so when I integrated JavaScript into that, I didn't realize this. So I started saying, okay, I'm going to put a callback here in the middle of Eric's layout routine that creates a form element, and I'm going to create a JavaScript peer object to match that element. It will be the peer of that internal C data structure. Unfortunately, because he was doing table layout repeatedly to measure things, I get 2 to the n of these things. But I also realized because HTML at the time had no restriction on the name element, you could have things named foo 3 or 5 or 100 times in the same document, that I would automatically array them. So if you said 1 foo, you get a singleton. If you said 2, you get an array of 2 elements named foo. And 3 would just append to that array. And so totally accidentally, his layout multipass 2 to the n characteristic interacted with my JavaScript automatic arraying to create a form element that was basically an array of individual form elements. Only the last one was the real one. The rest were all sort of throwaways used for measuring the table dimensions. And so this particular contractor I mentioned who was saying, I've got a demo on Monday, I'm going to get fired if I can't do it. He couldn't make the element come to life. And I said, oh, you're using like the first element, or using the array. That's not the one to use. You want to actually drill down 1 level deeper and go to length -1 element. That's the real element. And when he did that, and suddenly it started responding and showing that it was the real element, you could actually change its attributes and have it have effects on the presentation. he was like overjoyed, and so was I. So, there's a real kick in helping people get workarounds to these things.
That's funny.
That's awesome.
That's awesome.
Did any of these workarounds become enshrined into the language and then you regretted them later?
Yes. Many of them. I mean, you can't avoid some of the sort of DOM level 0 stuff is codified in HTML5 thanks to the work in the WhatWG that we started with Apple and Opera when I was at Mozilla in 2004. And some of it has been warped through the IE4 lens. But a lot of the early stuff's there, like the name attribute instead of the ID attribute we all know from more modern HTML came via XML. The name attribute is kind of funky, and you can get sort of automatic arraying of things, like radio buttons automatically array. And I'm not sure if the old property that all form elements automatically become arrays if there's multiple instances with the same name is still there, but that was there then, and that was part of the workaround I mentioned. The vision I had, though, was bigger. I had maybe a few weeks while I was still on the server team sort of thinking ahead, trying to plan, because I knew I was going to transfer to the client team. And I thought, how could I make JavaScript and demonstrate its value against Java and get it into the browser really fast? And I thought, how can I make it easy to use for beginners? Because that was the big pitch that Marc Andreesen and I, also Bill Joy of Sun Microsystems, who signed the trademark license in December 4th, I believe, that gave Netscape the right to call it JavaScript instead of LiveScript. The Mocha name was allegedly contested because there's software that uses Mocha in some sort of name. And so Netscape chickened out on Mocha, and they hired somebody who liked LiveScript, and that was a lame name in my opinion. And so what they really wanted was to call it JavaScript, and they finally got the license through Bill Joy. And what Bill Joy and Marc Andreesen and I all saw was you have to make this really simple for beginners. And so did you even want it to look like Java, which is a C-like language? I started looking at languages like Logo and Smalltalk and Self and HyperTalk, which was Bill Atkinson's language for HyperCard.
What about Visual Basic?
Visual Basic, no. I knew Basic from when I was a teenager, and a friend had a Commodore PET, and he wrote a Star Wars trench game. It was like a 2D vector graphics trench game where you're like flying down the Death Star trench trying to shoot at the exhaust port. And I knew Basic, but I didn't think that would work in the modern era. And I was attracted to Self in particular because it was taking ideas in Smalltalk and simplifying them, trying to minimize the number of concepts and then maximize their utility. And that was, David Unger and company, and it was good work. They also did optimizing of powers for it, which they founded a company out of Stanford called Anamorphic. And I actually, a few years later at Netscape did, on loan to Sun, did some due diligence when Sun acquired Anamorphic. And Anamorphic had Lars Bach and others as like the young programmers doing all the heavy lifting for the senior people like Dave Unger and Craig Chambers on what became the Self with classes jitting VM and the Strongtalk VM, which was Smalltalk with types. Gilad Bracha did the work on the type system. Eventually that open sourced, and that led to V8, if you can believe it or not. From the names I've dropped, you probably can believe it. So there's a lineage here that goes from JavaScript through Java, because Lars went to Sun and worked on, Lars Bach went to Sun and worked on the Hotspot VM, to JavaScript in V8, and now to Dart. But long story short, there was an idea in JavaScript that I was pursuing, and maybe a few others saw it too, of a language that wasn't C-like. It was easy to use. It was meant for people who were building things inductively. They were learning programming for the first time. And they didn't necessarily have to know about where semicolons had to go or even curly braces. I lost the curly brace front. On the semicolon front, I said, it's ridiculous to reject a program because of a missing semicolon. We should do some kind of error correction procedure. So I made one up on the spot, and that became automatic semicolon.
I kind of hacked this in, and it stayed.
Yep.
And 15 years later, people are still fighting
every
over it.
programmer's nightmare,
It's
right?
so true.
Just the
I felt
hacky
a
thing
sudden
you make.
tremor in the force, as if 1,000 semicolons suddenly screwed up everything.
Yeah, there are definitely some issues there, but in fact, I remember Jamie Zawinski was writing some JavaScript, and he had a long return expression, so he put it on the next line with no semicolon after the return. He was outraged that ASI would insert a semicolon after the return, making the return the undefined value, and the next line becomes dead code, a useless expression. It's unreachable in the control flow of that function. He was totally outraged, but I said, it's too late. I can't change it. Once you ship things on the web, it's very hard to change them.
Yeah. So I kind of want to skip up and talk about So you got this thing going. It's JavaScript. It's successful. How many other people adopted it before you guys decided to give it to ECMA and let ECMA kind of standardize it?
Netscape was the hottest name and the sort of the name that put the browser and things like URLs and the web on the map. Wasn't Mosaic. We killed Mosaic, and then we were the hot thing for like a year and a half. And during that time, it was awesome because Microsoft was behind. Bill Gates realized that they made a mistake. They were doing sort of an AOL killer called Blackbird, which was like a proprietary content system for a dial-up network. And when Gates saw what was happening with Netscape, he said, we're going to lose unless we jump on this and, embrace, extend, and extinguish it. They actually tried to buy Netscape in late 94, and they offered like 100 million or something paltry. So they were told to get lost. And that meant they went and cloned it, and everybody knew it. When I joined Netscape in April 95, it was like, we're doomed. People were just thinking Microsoft was inevitably going to kill the company. It was only a matter of time. And at that point, they'd acquired Spyglass, and they started, sort of digesting the source code and then creating IE. I don't know if there was an IE1, IE2, IE3 in 1996. IE4 was coming out in 97 in like preview releases. And that's when it got really good. So there was a real concern about Microsoft killing Netscape fast. But before that got huge, in late 96, they were putting moral pressure on Netscape. Like Bill Gates would say, Netscape keeps changing the semantics of JavaScript. And I'm like, oh yeah, like you never did that to Visual Basic?
Yeah.
And like they didn't do it later on in IE.
If you follow Visual Basic, there's this crazy mistake they did where they blended it into .NET and they called Visual Fred or VB7, and it completely flopped. But even VB6 was like incompatible and weirdly different from previous versions. And I was like, pot kettle black, hello. But the pressure through developers was enough. And the fact that they were coming, like Mike Homer, the marketing VP at Netscape, said the monster truck was like in our rear view mirror. Netscape's in its little Yugo, like the pedal to the metal, topping out at 50 miles an hour, heading toward distant horizon. And behind us is this monster truck that's creeping up, and it's kind of far away, and this little dot, and it's getting bigger. And suddenly it's like its bumper. You can read the print on the bumper. And then you look ahead and you realize it isn't the horizon you're heading toward, it's a wall. This is all Mike Homer's metaphor. And so what do you do when you're heading toward this wall? Ultimately, the executives decided to do Mozilla.org. They said, hard left and hope for, somebody to survive. Don't let the monster truck run you into the wall. Release the Netscape source code as open source. But before that happened, that decision was like late 97, leading into April 1st, 98. Before that happened, there was, let's standardize JavaScript. Okay, we don't like the moral pressure from Microsoft. Hypocrites they are. We don't like being held to account for not standardizing the language. Let's take it somewhere. And so this guy Netscape hired to be their standards guru named Carl Cargill, he said, I know how to do this. He was friends with Jan van den Belde, who was Secretary General of an outfit called ECMA, recently called the European Computer Manufacturers Association, but they decided they wanted to be worldwide and the European was too limiting. So they said, it's not an acronym, it's a proper noun, capital E, lowercase CMA, ECMA. And so they started renaming themselves and saying, let's do software standards. And if you look on their core agenda of standards at the time, it had things like Fortran standards and COBOL standards. These were all kind of long-standing ISO standards they kind of embraced or wrapped up, repackaged. They also did a bunch of novel standards based on optical discs of the time. So Philips was a big ECMA supporter. And getting into software with Netscape was good for them, so they went for it. Carl liked it because Microsoft didn't have any particular power with them. And in fact, ECMA, I think before Netscape did JavaScript through ECMA, ECMA had done de jure standardization of the Windows 3 API. Windows 16-bit API, because the European governments, this was pre-EU, had demanded that be standardized since they were all dependent on it for their infrastructure using PCs. They said, we must have a standard for this. Microsoft wouldn't do it, so ECMA did it based on sort of open knowledge, open docs and specs and man pages or whatever the equivalent Microsoft had was. And Microsoft actually sued them over that and lost, I think. So Carl thought, this is a great way to wrongfoot Microsoft. We'll take JavaScript to ECMA. And Jan van den Belde was a raconteur and a very learned fellow. He was born, he's got a Belgian surname, or a Dutch surname, actually, Van den Belde. Dutch surname, born in Belgium, lived in Geneva, knew everybody, We had great dinners out in Europe, I'll have to say that, when we went to standardize JavaScript in November 96 through June 97. When we finally finalized the standard in June, it was in Nice, and it was a good event. It had people from IBM like Mike Collishaw, IBM fellow, now retired. It had people from Borland, Microsoft, Netscape, other companies. Sun loaned I'm saying Bill Joy, but I mean to say Guy Steele, total CS god from the Scheme era. Guy Steele and Gerald Sussman did Scheme. So that was like, I was in awe. It was great to work with them. And Guy knew everything about like things like floating point. In fact, if you wanted to do floating point number to string and string to number conversions, the canonical paper still is one by Guy Steele and David M. Gay on this. And there's still like some C code that everyone uses. It's like ugly 70s C code that David Gay wrote, but it's the code to use for converting accurately, because it turns out to be very hard to convert decimal strings of digits after the decimal point to binary fixed precision IEEE double. You have to carry extra precision around to round correctly. So that code and that standard was very helpful in ECMAScript. And Guy was there. And Guy even brought Richard Gabriel, another Lisp god, also a poet, who was associated with Stanford at the time. I saw him at OopsLaw a few years ago, but I haven't kept up with Dick. But he was a lot of fun. He wrote Clause 3 of the ECMA standard, which is sort of the intro. It tells you about what JavaScript's about, sort of objects and functions, objects without classes.
Wow. So AJ wants to know where the name Mozilla came from.
Yes, I do want to know that.
That's actually on the web. So if you read Jamie Zawinski's many posts on his site, he named it based on the idea of a mosaic killer. When Netscape realized they weren't going to do Nintendo 64, modem networked software, they said, let's do a mosaic killer. And Jamie started musing about mosaic killer, giant monster that kills mosaic, Godzilla, Mozilla. So that's where the name Mozilla came from.
Oh, that's funny.
That is cool.
Deploy more, pay less with DigitalOcean, the simplest all-in-one cloud computing platform for developers. Scale and run cloud applications faster and more efficiently with effortless administration tools to robust compute, flexible configurations, networking services, real-time alerts, and rapid provisioning, while enjoying industry-leading price to performance with a flat pricing structure across all global data center regions at any usage volume. Spend more time building better web apps and less time worrying about managing infrastructure with DigitalOcean. Build your next app on DigitalOcean. Get started with a free $100 credit at do.co/adventures.
I feel like I should explain more of the DOM level 0, like set timeout. Kind of wacky because people use the form that takes a function as the first argument, and then it's awkward because you put the timeout in milliseconds after that, and then if there are any actual arguments to the function, you pass them after the timeout, so they're kind of interrupted by that timeout value. The original version that said timeout in Netscape 2 did not have the function argument. It only had a quoted string, which was evaled. So you wrote an expression to be evaluated in milliseconds. And in Netscape 3, we added the function for, and at that point, it was too late to reorder the arguments because you can't break the web. And so that's why it's function timeout arguments. And you can still use the string form.
I always thought that was better anyway, to put the function first, because then it's composable.
It's a mixed bag, right? If you want to have something that sort of applies or does partial application, you end up having to juggle the timeout and the arguments list. But you can do it.
So I have a question. Why did you make functions first-class citizens?
So that was, people say JavaScript is inspired by self. There was very little self, in fact, because I had so little time. And self has, like things like lexical scope. So you have no conflation of objects and scope ribs, which JavaScript had and has due to the global object and the width. But I did at least have the sense to make functions first class, which self does and Lisp does. And I realized if I didn't do that, I didn't have much. I was in such a rush. I mean, it was 10 days till the demo in front of the engineering team. And I thought, how am I going to do this and make it useful? I had to lean on a very few concepts that were powerful. One was functions, and the other was, and closures were only sort of latently there in the very first version. The other was sort of objects you could create ad hoc. So functions were huge, and not making them first class meant I was going to have to lock them down and get it all right and make the global object and built-in functions and the math object, make that all perfect from the first release. And I knew there was no time to do that. I realized that I needed to allow people to mutate the environment. I needed to let everything be mutable. in order to patch, monkey patch, polyfill. I didn't see the whole, evolution where people would actually anticipate standards by polyfilling, but I did know that I could get it right, and I had to leave it open. It is basically one bit of decision logic. Do I make it open and immutable, unsealed, or do I make it closed, locked down, and sealed? And I said, if I make it closed, I'm screwed. And in fact, Java's world was much more closed, and that hurt them.
So you mentioned Java again. I just want to clarify because I'm not sure I got my answer out of your story. Did you call it JavaScript just because Java was popular and you partnered with Sun?
Like I said, Marc wanted to call it Mocha. I didn't care, except I liked Mocha because it was different. I didn't know of any prior art, but apparently there were software trademarks involving the name Mocha, but they were not related to a scripting language. So Netscape could have probably fought for Mocha. When they hired the marketing guy who said everything's going to be live script, we have Livewire, which is like a server PHP-like project that would allow you to do sort of configuration management and simple database query-based apps. It was very much like an early PHP. He wanted to call it Livewire. So suddenly everything was live this and live that. And I was kind of throwing up my mouth a little bit. I didn't like that name at all. So when they came around in December and got Bill Joy to sign the trademark license for JavaScript, I said, okay, I'm not sure this thing's going to make it because I was the only programmer working on it throughout 95. I was it. I had no support other than the part-time help from the front-end folks who did the form and the sort of presentational stuff that had to update when you have JavaScript poke at the DOM. And the DOM wasn't totally two-way. If you poked at certain things, it wouldn't update the online presentation. You couldn't do text ranges. You couldn't do arbitrary layout. You had to poke at text in a text area or a text input. So I was a little worried JavaScript wouldn't make it. And I thought if we're going to have some juice here, we might as well use JavaScript's juice. And also, I like the fact that Joy signed the trademark agreement because everybody else at Sun hated JavaScript, and that really cheesed them off.
That's funny.
Yeah, nowadays, Sun, you mean Oracle, you mean... Nah, never mind.
Some of the people there are still people working there I know from the old days, like John Rose, who did like Nashorn and made sure Invoke Dynamic, which is what we would call like a JITted polymorphic call site instruction, got into the JVM. So, my hat's off to them. They're like long old timers who want to keep evolving the JVM. And in fact, the JVM is a great VM. It has lots of languages like Clojure and Scala, but it's a server-side VM. There's no way it could have survived on the client. Sun thought they had a shot when after they saw JavaScript getting standardized successfully, they said, okay, we're going to take Java to ECMA. And this was like 98 or something like that. They sat down with Guy Steele again. They ordered Guy to go do his duty and standardize Java. And they had Microsoft for a time and others sitting around the table. Sam Ruby at IBM was there. And Guy said, okay, we have 1 year. We have 7,000 pages. We have 39 seconds per page. We have to go now. And so we have to rubber stamp every page in the spec. And it didn't happen. That was not a good way to do it because there was too much to specify, not just the language, but the VM and sort of the memory model, which wasn't even fully understood then. I think Hans Bohm at HP Labs had helped figure it out. And meanwhile, Microsoft decided they didn't want to play ball with Sun. And so at some point, they yanked Java from Windows. If you guys remember the history, and that led to something we all know and love called XML HTTP request, that because Outlook Web Access needed Java to do asynchronous, like XML HTTP requests. Once Microsoft decided they were breaking up with Sun, they were going to yank Java, and there was a lawsuit around that they needed a replacement for the Java async IO class, and so they just hacked in XHR. That's how XHR came about. It was totally based on this fight between Microsoft and Sun.
It's so crazy because it's such a convoluted story.
Yeah.
I mean, you could imagine ways where XHR wouldn't exist, and then the web would be totally different.
I'll tell you, having a hidden form or a link you click was a pain. XHR, for all its funkiness and, crap like the synchronous option, it's better than what was there before. But all of it's kind of random. It's like evolutionary biology. You don't really get to choose. You just take what works, and you're lucky if you survive.
So was XHR all of Microsoft's invention?
It was, but again, it was cloned. It was kind of filling a vacuum that was left when they kicked Java out and they needed to keep Outlook Web Access working. So, some of it had the sort of flavor of Microsoft and Visual Basic informed API. Some of it was based pretty closely on the Java async IO class that they booted.
Did you ever look at this like baby that you created and at certain points wonder if something was going to kill it off, like, say, Flash, for example.
Oh, absolutely. I mean, first of all, I was kind of done working on as a lone gun on it. I had some help. Ricardo Henez, who's working on some kind of Hadoop startup now with friends I know from Yahoo, like Remy Stata. I forget the name of the company, but Ricardo came in to help me. He ported the David Gay floating point number to string and back code. And early on, there was a guy named Ken Smith from Netscape, acquired from Borland, who did the date object based directly on JDK 1.0, the Java Developer Kit 1.0 version of Java util date. So all that crap people hate about the data object, like months are numbered from one, a number from one in normal human calendars, but are indexed from 0 in the Java till date API and therefore in the JavaScript date object. People hate that. The Y2K bugs, get year instead of get full year, a 2-digit date offset from 1900. That was all from Java. And it was like a Y2K bug. It was like an office space. That came directly from Java. It was Ken Smith basically transporting C code implementing, or Java code implementing Java util date into JavaScript or into the C part of the engine that implemented the data object. But other than those guys helping out sort of on pieces, I had no help. Until late 96, one of the Netscape founders, Chris Hauck, decided to join me. And I felt pressure in joining the ECMA group to make the language cleaner. So I started to rewrite the VM, pay off technical debt, and I became SpiderMonkey. The original Mocha VM was not SpiderMonkey. It was much slower. It was a Rust job. When I rewrote it as SpiderMonkey, I had a garbage collector. I had things that I thought were better done. I had tagged values, sort of machine words with low order bits that told you what the type was. I took 2 weeks away from work where the VP in charge of me was saying, you better get in here. We're trying to standardize this. You have to write a language spec. And I said, get lost. I'm re-implementing it. I have to implement it before I specify it because it really was based on the code. It was based on what actually shipped. It wasn't a matter of writing down some platonic perfect JavaScript because there wasn't any such thing. It was all about what actually was in Netscape 2 or 3 at that point. And so the JavaScript engine got rewritten in 96, and that finally shipped in Netscape 4 in 97 or 98. And that helped me keep my head up in the JavaScript standards body, the ECMA TC39 group. Because the first meeting of that group, even though our guru, Carl Cargill, had thought we would have the advantage inside ECMA, Microsoft sent in a lot of people. Now, they were kind of the B team. So one of the guys was funny. He actually made the joke that I've used since then that, well, we can't really call it JavaScript. That's a Sun trademark. And Sun was, suing people whose surname was Javanko, like a Middle European last name. They were saying, this guy is on the web. He's got his website called Javanko.com, and it's named after his ancestors going back to, thousands of years. And Sun lawyers call up and say, you must cease and desist using the name Javanko. It's not your name. It starts with Java. It's our name. And he said, get out of here. It's my ancestor's name. So Sun was stupid. They didn't want to give the name away to the standards body. So ECMA said, we'll call it ECMAScript. And one of the Microsoft guys, I forget his name, said, that's not a really good name. It sounds like a skin disease. and he was right. Yeah. But because I was actually re-implementing and I was kind of all over the language semantics, I easily defeated them in these various little debates about how to standardize it. And there was a wacky guy from Borland who thought he'd implemented JavaScript and he had it all differently implemented, not interoperably implemented, because he wasn't building a browser. And there was this company called Nombus, no MBAs, that was founded by the son of Ray Norda, who was running Novell at the time. And they said, we've been doing JavaScript for years. And I said, really? I only created it last year. How can you be doing it for years? And what they meant was they were doing it like a C-like scripting language. And of course, all the detailed semantics differed. But we finally got the committee to codify mostly what was shipped in Netscape. Microsoft, after that first meeting where they didn't send their A-team, sent their A-team. And that was Sean Katzenberger. He's very smart. He went to work on .NET with Anders Hellsberg after that. And he actually told his bosses, he did what I did, only more so. He told them to get lost. And he spent like 6 months working on what became the first edition of ECMAScript as a spec. And Guy Steele did a fair amount of work and others contributed pieces, but Sean did the sort of backbone and the main part of the work. 6 months to work on what became the first edition of ECMAScript. And he came up with this formalism for the data object because the Java-based data object was crazy. He just said, let's make an extrapolated Gregorian calendar. It goes plus or minus 200,000 years because we have that much accuracy, precision within IEEE double if you count milliseconds. And he was very smart. He did a good job and didn't really seek advantage. There were a few things that I thought that he wanted to push that weren't right, but it turns out I dug through my mail archive when I met him, and I realized he'd mailed me months earlier, like in 96, saying, hey, there are things in JavaScript. Maybe you can change them quickly before it gets too hard to change on the web. And when I found that mail, I realized I'd skipped it quickly because I realized I couldn't change it even then. Like Marc Andreesen tells the story that NCSA had like 80 web servers in the whole world, including CERN, the original web servers from Tim Berners-Lee, and they couldn't change anything. So Netscape 2 beta, we shipped JavaScript and it's LiveScript. And even then, with early adopters writing code, that contractor with his demo I helped rescue, you couldn't change it. So there's this survival advantage to keeping compatibility, and it's real. And that affected us all the way through this, and it affected Microsoft too. So here's the punchline. When I redid the implementation and created SpiderMonkey, I said, the double equal operator, I was being spun around by the Borland guys who wanted very loose implicit conversions. I was looking at Perl 4, which had all sorts of crazy. That was a mistake. I want a real equivalence relation, except for, nans. I want something where you have reflexive, transitive operator, and it partitions all values into equivalence classes, which are as small as possible. Let's make the double equal operator be like what we know as the triple equal operator. And I said, I know it's incompatible. I'll have people call it JavaScript 1.2 and they'll have to opt into it. They'll say script type equals application JavaScript 1.2. Microsoft guy said, well, you're right. You can't do this like without any type equals opt-in. And nobody's going to use the opt-in or they're going to get it wrong. So it's too late. Let's just add triple equal. So that's what we did. Even then, it was impossible to fix mistakes in the language. This was 96, 97.
So why'd you call it SpiderMonkey?
There's a Wikipedia page, which obviously somebody from Netscape has over-edited because it half explains this, but it doesn't quite link to the correct explanation. If you look for Beavis and Butthead Tom Anderson, SpiderMonkey, you'll be enlightened.
All right.
The name was given by Chris Hauck, Netscape co-founder.
So, I want to go back to this ECMA thing. I watched some talks at Yahoo where you and Douglas Crockford both gave two different explanations of this falling out. And I think that you compared it to the Lord of the Rings.
Oh, this was like the 4th edition falling out? Yeah, right.
And he compared it to something like The Good, the Bad, and the Ugly, didn't he?
No, that was me also.
Okay.
That was my TXJS 2010 talk, I think.
Okay.
So, yeah, Doug, I don't know, Doug didn't have a good metaphor for it. I made it The Lord of the Rings. I actually had lots of fun trying to find Doug's avatar. I started with Yoda, but I realized he was too short. And I said it has to be Gandalf. And so it was Gandalf. He was like on the bridge of Khazad-dûm, fighting the Balrog, the ES4 and the hobbits were the JS hobbits were being defended from having to use this horrible, classy, fancy, complicated language. ES4 was an attempt. There were several things. It was an attempt by Macromedia and then Adobe, which bought Macromedia, to standardize the fork of JavaScript called ActionScript that they put in the Flash player. And they actually done 2 versions. One was ActionScript. Maybe they've done 3. The original ActionScript, now ActionScript 1, was pretty much JavaScript, probably some minor differences. ActionScript 2 had a few more things, but was still mostly a dynamic language. And then ActionScript 3, implemented by the Tamarin engine that they finally open sourced through Mozilla in late 2006, was quite different. It had classes, packages, namespaces, types, optional type annotations, machine types. You could do int32, and it felt like they were responding to a lot of Java envy or Java angst among their sort of Java-trained developers in the Flash world of 2006 or 7. And they wanted to standardize that through ECMA as a sequel to the 3rd edition of ECMAScript. I wanted to get Microsoft to play ball and evolve JavaScript as it was. When I started Mozilla and started Firefox, and we launched Firefox 1 in November 9th, 2004, I realized this was going to restart browser competition. So I rejoined ECMA on behalf of the Mozilla Foundation as a not-for-profit member, which was awesome because you don't have to pay. And then started collaborating with Macromedia, soon to be Adobe because they bought up Macromedia, to evolve JavaScript. And we did, as a warm-up, we did E4X, which was this crazy XML syntax inside JavaScript that was done by BEA. If you remember them, they were sort of a Java app server company. And John Schneider, then at BEA, who had been at Microsoft, and his buddies at Microsoft, like Rock Yu, who was actually running the ECMA liaison for Microsoft, decided, let's do E4X. So we did this ECMA 357 standard that tried to standardize ECMA script for XML. It was an add-on to the JavaScript standard, and it put XML literals into the language. It also put namespaces in, including the double colon qualifier to separate the namespace from the name. All sorts of crazy stuff. And it had lots of footguns, in my opinion. It was very much based on an implementation that was done in Java on Rhino, the Mozilla Java implementation of JavaScript. And it became a dead standard ultimately. It wasn't really implemented by anybody else, not even by Microsoft. But Microsoft, for a time, there was talking a good game. They had said, while Netscape was still alive, yes, we'll do JavaScript too. And yes, it will be classy. It will have classes and packages and namespaces. And they even implemented some of those things, their own spin on them, in JScript.net in 2000 era. And you can find web pages to this day that talk about JScript.net and classes in JavaScript. But they backed off on it when they got serious about C#, and they kind of reneged on the whole thing. And they also, other than Rock Yu, this fellow who's left Microsoft since then, long ago, but he was a fun guy. He was the liaison to the ECMAScript standards body, and he was doing E4X, even though he was not selling it inside Microsoft, and nobody was implementing it. So I used E4X as a lever to get Microsoft's engagement and attention, and to get JavaScript standards body back in business. So we reformed what was basically disbanded in 2003. Microsoft had crushed Netscape in the browser wars. The Mozilla Foundation was spun up in summer 2003 from an AOL layoff. And the person I'd given the keys to the kingdom for JavaScript to, Waldemar Horwath, Netscape, very smart guy. I think he won the Putnam math exam in 1986. If you know what that is, that's pretty impressive. Waldemar was from MIT. He was a PhD. He was working on a Java virtual machine. This was not the original early days. He was going to do a full JITting, like hotspot style JVM at Netscape in 97 called Electrical Fire. But Netscape was running out of money because Microsoft was killing them by taking the price of the browser to zero and also doing a better job on the server side. Netscape could never make server business pay. Waldemar was looking for a job, so in late 97 I said, hey, why don't you take over JavaScript and standardize it and take it to the next level? So Waldemar worked on JS2 or early ES4, what you might call as primitive ES4, and you can still find his design documents in the web archive on this. And that fed into, in its own way, into E4X and into ES4, the final real ES4 that we tried to do in 2006 through 2008. So we tried to evolve JavaScript aggressively to absorb and embrace and extend the Flash player version of it, the fork of the language that was in Flash, the ActionScript language. We also tried to do it, this was my own agenda, to get Microsoft to start evolving it again and stop sitting on the web. Because you guys all know this, right? After IE6, they kind of took the team down to a skeleton crew, and they stopped fixing bugs. They had horrendous security bugs and page layout bugs and DOM bugs and networking bugs. And they just said, the web's over. We're going to do Windows Presentation Foundation, which became Silverlight. We're going to do .NET. You know, the web, that was a passing fad, sort of like television. So,
it's a toy. The web's a toy.
That's right.
Until Firefox started taking market share back from IE, they were confident that was true. And then they were like, oh shit, we better actually do IE7. Oh wait, we haven't really done IE7 right, let's do IE8. And then finally, when Firefox triggered enough response from Microsoft and Google that Google did Chrome, then they really woke up and did IE9. But think back to 2006 or 5 when I was doing E4X. Microsoft was just kind of asleep at the switch. And so I said, how am I going to poke them? I have to sort of stick the stick into the hornet's nest and stir it around. And the best way to do that was to use Adobe, to use E4X, to use ES4. And so the thing you mentioned with Douglas Crockford was, at first Douglas Crockford was on board. He was at Yahoo. He thought, well, we have to repair the defects in JavaScript because Doug, wants just the good parts to be there. He wants to get rid of the bad parts. And like I said early on, it's very hard to remove things on the web. You can't really break compatibility. Nobody wants to do it. It's like biologically unsound, unfit. But Doug was up for it at first. So we met summer in Oslo 2006, and we said, let's do ES4, 4th edition. The 3rd edition was in 99, maybe 2000 was the ISO version. It's been a long time. Time to upgrade it. What can we do? And so various people had their own Rashomon-like interpretations of what happened. It was like the Macromedia, Adobe guys, at that time, Macromedia said, let's do classes. We want classes. And they leveraged Waldemar Horwath's design work from 6 years earlier at Netscape. And they put that into what became Xamarin and AS3. It wasn't shipped yet. And they were making a big bet that they would all get standardized. People like Douglas were like, let's take out the bad parts. People like me were like, let's get Microsoft to actually work generatively on JavaScript. So you can tell it was not going to work out, but it did get things moving. And so we had ES4 and it got so much design attention, almost it was over-designed, frankly, that it became a big threat. And so by 2007, January, Douglas decided, no, this is too big and it looks like Java. It's classy and I like things small and simple and I want to take out the bad parts. So this is all wrong. And he forged an alliance with Microsoft. Now, it may be coincidence, but at the time, Microsoft was considering buying Yahoo. So when we were heading into a spring meeting hosted at Microsoft Redmond, Washington, near Seattle, Douglas was there early. And he was having meetings on his own with Microsoft people. And we're like, wait, what's up? And then Chris Wilson, now on the Google Chrome evangelist team, was at Microsoft still on the AiA team saying, oh, we don't really want ES4. It's too much. It's too incompatible. By the way, I agree with some of that. And we can't have any of this. And Doug was there. I think Jerry Yang broke his heart because Jerry did not accept what probably was the best offer Yahoo could ever get. So that all fell apart. But still, it led to this public fight over ES4, which you guys probably remember from my blog post of the era. And it was like I wrote an open letter to Chris Wilson, like it was not totally serious because what I was trying to do was get JavaScript to evolve. What Microsoft was trying to do was still push Silverlight, maybe help JavaScript. And it turns out they didn't know what they wanted to do. So they had people like Alan Ware-Sprock, who then jumped to Mozilla. But at the time, Alan was working for Microsoft, and he became the editor of ES 3.1, which became ES5. And that was their, like, let's do something less than ES4. Let's do 3.1. Let's do a no new syntax version of ES3. So Alan did that for Microsoft, and he had Doug on board and others. And again, Doug couldn't remove the bad parts, so I think he lost interest. But Alan plugged away, and between ES4 being overdesigned and Alan finding sort of the APIs that were missing, like object.define property, a lot of us realized, hey, this is a good intermediate step. It almost gives us a compile to language for ES4. And so we folded up the ES4 tent in July 2008 at Oslo. And Opera, which was an ally of Mozilla on ES4, along with Macromedia, come Adobe, Opera had somebody really strong, Lars Hansen, who had written their Futhark JavaScript engine. He was all on board. He jumped to Adobe because he wanted to keep working on AS3, but he was also instrumental in this. I think Adobe realized it wasn't going to get standardized, and they were feeling it was a waste of money to invest in the standard. They were feeling, maybe some of them felt betrayed by Mozilla, though we didn't actually betray anybody. We just said, we can't say no to ES3.1. It's a good intermediate step. Let's do that. Like a year later, we said, we'll call it ES5 and we'll just mothball ES4 as something that never shipped, and on to ES6 in the modern Harmony era. So I forged the Harmony agreement. I was like the rainmaker and the peacemaker, the group hug arranger. And I wrote the email that's on ES Discuss still. It talked about ECMAScript Harmony and what was excluded and what was permissible to include in future versions based on this new piece, this new era of peace, this like Treaty of Westphalia, if you will. So that was all 2008. The funniest story, which I'll also share here exclusively with you guys, is Alan Ware-Sprock jumped to Mozilla, and I worked with Alan, and he's still the ES6 editor. Alan said, yeah, right before you guys folded on ES4, Microsoft was about to fold on it. They were about to say, I guess we better implement ES4. It looks like it's going to happen. And so it was like,
dang it!
It was like poker, and we didn't bluff hard enough. But it would have been a mess. It would have been a total disaster to have this over-designed language with classes, packages, namespaces, all sorts of like quasi-static typing. We weren't sure exactly how to make it work. We had sort of dynamic checks based on annotations, not just like Dart or TypeScript, but actual runtime checks compiled from like annotations and colon annotations. This stuff was half-baked. There's still interest in this in the committee. There's obviously things like Dart and TypeScript. They erase their annotations, so they have a check to mode option where you can turn them into runtime checks. That's only for like testing. When you actually deploy, you erase them all and you just generate plain old JavaScript. So the type system is formally unsound. There's other reasons it's unsound, but at the very least it's unsound because it lets stuff escape into runtime that could could have an exception, a type error. But you know what? That actually has found a lot of adoption. So I think it's useful. And what's useful may not be sound. And so there's actually a chance, this is controversial in the ECMA committee right now, but maybe in a future annual edition of Harmony era JavaScript, we'll have optional types. I don't know. They won't be like ES4. ES4 tried to make them actually mean something. And that's extremely hard on the web because you're always loading code and you load new code that renders your old type judgments invalid. What do? Do you recompile the world? Do you throw a type error about the mixture being incompatible when the old code was already running but the old code was the basis of your Gmail user interface? It's because you load new code that invalidates those old type annotations doesn't mean you should break your user Gmail experience. It doesn't make any sense. So JavaScript is fundamentally dynamic, and you see all the value in TypeScript and Dart coming from the tool time sort of advisory checking, the warnings. Like when I was at JSConf AU in 2012, I made the joke that, well, it really isn't a type system, right? They should have called it Warn Script, but Warn Script's not very good.
So I'm kind of curious. We've kind of talked about where JavaScript came from. We've talked about where some of the features, some of the controversial features have come from. I'm a little curious where Mozilla comes in with all of this.
So Mozilla was the thing that I worked on after JavaScript and Netscape. In some ways, I've always worked on the same thing. It was like JavaScript, the SpiderMonkey rewrite. I realized that I had all these early adopters, like that contractor who had that demo that needed to know that table layout was replicating his form elements, and he really needed like the length -1 element. And I realized this would all be better for open source. I shouldn't be like hiding anything from these people. They need to have workarounds. I need to have code fixes or bug reports. So I got very interested in open source. So did Netscape because they wanted to do a life pod. It was partly executive vanity project, and partly Mike Homer is metaphor of the Yugo being chased by the Microsoft monster truck into a wall. Literally, you'd do better if you did do a hard left and tried to bail out like some action hero. So Mozilla was that bailout. It was that hope that you could dive from the Yugo, roll in the dust, and get up and then have another sequel movie that was even more exciting later. And so Mozilla in 1998 launched with the Netscape code base, which was all the student code plus my SpiderMonkey engine re-implemented in 96 and 97 and integrated into Netscape 4. And it was spaghetti. It was a mess. It was mostly C, and it was rushed, and it was full of technical debt. And early on, we had very few contributions to the Mozilla project from outside the Netscape employee base. So we started with everybody who was a committer. This was in the era of CVS, before Mercurial, before Git, before the modern distributed version control era. We had CVS server that was hosted by Netscape. We had a few contributors from outside who'd submitted patches and gotten the permission to actually commit directly. Some of them had done things like replace the crypto module, because in 1998, the U.S. government, ostensibly through the Commerce Department, but really through the NSA, would not let you export a crypto module. You could not export the crypto algorithm suite required for SSL. So when we released Mozilla Code in April 1st, 98, there was no SSL. There's no HTTPS. And pretty quickly, some people down under, Eric A. Young and Tim Hudson, somebody I met when I was at SGI, coincidentally, had hacked an early version of what became OpenSSL, which was at that point called SSL EAY, Eric A. Young. SSL EAY, they'd hacked that into the open sourced Mozilla code to provide the missing crypto algorithms to provide HTTPS. That was one of the biggest, most impressive hacks that was done by open source contributors. But other than that, it was such spaghetti, second generation student code. Hardly anyone could do anything with it. And so I was the technical leader of Mozilla. I was like the architect. I said, we can't have this. We have to do something that's more greenfield, that allows homesteading by new contributors, that allows people who care about standards to implement things correctly instead of hacking on this, very non-standard code base. And Netscape had acquired a company called Digital Styles that was known for building rendering engines of some kind. And they started doing a next generation engine in 97, I think, based on Java. And they thought, Netscape's doing the Java Gator. Netscape and Sun are going to kill Windows. Java's going to be the future. On the client side, let's build a Java engine. When Java got the plug pulled from it in late 97, when the electrical fire JVM that Waldemar Horwath was building at Netscape got canceled, when Sun went away because Netscape was basically going out of business, slowly. The team that was doing this Java engine, this Java web engine, rendering engine called Raptor said, oh, we better rewrite it maybe it was called Xena, I forget. They said, we better rewrite it in C++. And then they said, let's sell it to Mozilla. And I was looking, as a buyer, I was not just a chump. I was also looking for the greenfield homesteading space for the open source standards-oriented contributors. So we made a deal to reset the Mozilla project in October 1998 around rewriting everything from the ground up based on this Raptor engine, which got renamed Gecko. And around the same time, the KHTML project, KDE, was getting going. Now, we could have picked that, but it was also looking kind of raw, and it wasn't web compatible enough. And, Raptor was pretty raw. It had a lot of bugs. Gecko, early Gecko, had a lot of mistakes that we had to rewrite over the years. But we did get the greenfield advantage. We did get the web standards folks interested. We did get new contributors. And we did what Joel Spolsky describes as the big mistake. You don't rewrite your code base if you're in a competitive market. You do Netscape 5, Netscape 6, you do Netscape every year. You keep trying to fight for your market share. Netscape didn't do that. They basically trusted Mozilla to rewrite the code base. Some of the executives thought it could be done in 2 years, and I was like, no, 4 years. It turned out to be Netscape 6 was crapped out prematurely based on Mozilla 0.6. We wouldn't call it 1.0. It was so bad. You guys may not remember it, or you may not have been born yet. Netscape 6 was a disaster. It not only had like black and blue theme with circular buttons, it had like ICQ and AIM and other AOL incrustations, but fundamentally it was based on this crashy, buggy, slow version of Gecko. And so the Mozilla leaders, like Mitchell and myself, were like, no, not 1.0. You shouldn't ship this yet. The Netscape people living in fear of the AOL masters in Dulles, Virginia, were like, we have to ship or morale will fail. And we were like, no, morale's going to be bad if you ship. And what they really meant is that their necks were on the line as basically the acquisition that had to deliver some value to the mothership. So they shipped, and it was crappy, and it got panned. And I think there were some executive beheadings. And Netscape limped on for another year or two, 2001, 2002. And finally, we got Mozilla 1.0 done in 2002. And the best I can say is it didn't suck. It's like, at that point, you're not looking for ultimate victory. You're looking for something you can build on. It was a stable base for API compatibility. It was a stable release. And Netscape did a version 7 or 6.1 or 2. I can't remember the number. That actually didn't suck either, but it was too late for them. And then a year later in 2003, AOL pulled the plug on Netscape. But
did the ICQ integration say, uh-oh?
I think it did. There were a lot of things that were jammed in that were closed source. It was not good. And the funny thing was Mozilla doing open source only. At first, we didn't even provide binaries. You had to get your own compiler, like you were using GCC or EGCS even, if you remember what that is, a fork of GCC on Linux, or you were using, MinGW or Microsoft Visual C, or like this was pre-Xcode. It was like you'd use the Apple tools and PowerPlant, the user interface toolkit from Code Warrior. You use Code Warrior on Mac. This was old school. So at some point, we decided we're going to do builds because we need testers who don't have compilers to get the builds and test them for us. We don't want to make everybody be a developer who knows how to compile their own bits. And so by producing builds, Mozilla started producing product. We didn't even know it, but our Mozilla browser suite didn't have ICQ in it, and people actually liked it better. So we started getting adoption. And at some point, I can't remember when, 2001 or 2, we actually had more users than Netscape did. So at some point, we were getting the signal, very real signal from the market, the users saying you should do your own browser. And that's when I think David Hyatt, who went to Apple in 2001, who was one of the senior engineers there who did a lot of what became Zool. He and Blake Ross, who went to Facebook, and a few other people decided, screw all this Netscape browser suite, 90s era application suite where you have mail and news and ICQ and browser and editor and address book, like a Swiss Army knife application. Let's just do a browser and make it really awesome. And they called it Mozilla/browser, and then I think I was involved in this. We said, let's call it Phoenix, like from the ashes. And
I remember when it was called Phoenix.
Yeah, we kind of incubated it inside Netscape and sheltered it from management. And they were doing things. Even Dave Hyatt, who wrote Chimera, which became the Camino Mac-only browser, he was like practicing how to build a tab browser, how to build widgets, UI widgets in a cross-platform way, stuff that he then went to Apple and worked on Safari on. That all was like making fools of Netscape management because they were still like polishing the turd that was their application suite. So we ended up building what became Firefox as a sort of pirate ship inside Netscape. And then when AOL finally laid everybody off, Mitchell and I knew that was coming through back channels because Mitchell had already been laid off and gone to work for Mitch Kapor, guy who created Lotus 123, big investor, very well off. Mitch was employing Mitchell to work part-time on Mozilla, part-time on the Open Source Applications Foundation, which is basically, I think Mitch was inspired by Mozilla, and also Mitch always wants to recreate Lotus Agenda, if you know what that is. It's a PIM, Personal Information Manager. So OSAF was trying to do that as open source, like 12, 14 years ago, and Mitchell was working on it, but she was also working on Mozilla. Mitch Kapor knew one of the early AOL guys, Ted Leonsis, very nice guy, business guy, not a technical guy. Very well off, of course. He owns like the Washington Capitals, whatever. I like Ted, but Mitch and Ted ran into each other at the very first D conference, and Ted was like, "Hey, Mitch, I have this thing called Mozilla. I don't know what to do with it inside AOL." And Mitch, who coincidentally, or maybe this is fate, right, hired Mitchell Baker when she was laid off by Netscape, AOL, said, "I'll tell you exactly what to do with it," because Mitchell had been talking to him. So through these back channels, also through IBM, we knew that AOL was going to drop the axe on Netscape. They were going to like lay off everybody. Netscape had like hundreds of employees in this building in California. AOL was back in Dulles, Virginia, and they sent out some hatchet man VP. He had security goons behind him. They didn't have individual meetings with people. They just did it Jonestown style. They had everybody in one room, except for the people who went to the other room. And the other room was much smaller. So you had this weird day of event where the email went out and people were saying, "We're all supposed to go to the big room." And then somebody said, "Well, I'm going to the little room." And then people said, "Wait, is that good or bad? I'm going to the big room. You're going to the little room. Which one's good?" It pretty soon became clear that going to the little room was good and going to the big room was bad, because in the big room, the hatchet man said, "You're all fine people and you're all fired." And the little room involved people like me and David Barron and the build guy, Leaf, and I think somebody else still at Mozilla. It might have been Asa Dotzler. We were all sitting there, and we were not going to get laid off right away. We were going to have 3 more months, and we're going to transition the Mozilla assets to a nonprofit, which involved the trademarks and some build machines. Like, this is pre-Amazon Web Services, so it's just like we had like an Amiga or something. I don't know. We had a Sun OS machine. We had an IRIX machine. We had PCs. We had Macs. We had a very few rack-mounted machines we had to do our continuous integration on. And by the way, Mozilla did pioneer that with Tinderbox. That's something that's a staple now, and it's been done better. But at the time, Tinderbox and continuous integration was a Mozilla feature that I think was new to the open source world. A lot of open source repositories wouldn't even build if you went to their CDS. I guess I'm coming to another punchline, which is when we spun out Mozilla, we only had like 12 people, and we had Phoenix. Firebird, remember that name also was contested.
Yep,
so we had
I remember Firebird, yeah.
And we went to Firefox, but when we got into 2004, we knew we had something that was big. And it was like, you guys remember Chrome in 2008, it was hot. Firefox against IE was even hotter. And it was just amazing to be there then to do it, because you saw this opportunity to do a new browser and take back market share from Microsoft, which no one had ever done. And it was in a large part also associated with JavaScript, because people were realizing then, like, the Ajax revolution was starting. People, not Jesse James Garrett, but this guy in Sweden, what was his name? Daniel something. He'd written a paper about how you can do partial, like function prototype bind, partial application of functions in JavaScript. So people were rediscovering functional programming. So things were starting to look really hot as Firefox 1.0 launched. And AOL, I think, missed out. They could have had that, but they didn't keep it. They got rid of it. And that helped us, like I said, to connect to my earlier story, helped us rejoin ECMA and partner with Macromedia, then Adobe, and get Microsoft's attention and do ES4. And even though it didn't actually result in a standard, it provoked ES5 and Harmony. So, you look back and you see all these crazy accidents, these things that you ship that you can't fix later. And long ago, I used to hang my head. It was like everything bad in JavaScript, some of which I've forgotten, thankfully, cannot be fixed. But the good there is that that's the web we have, and you wouldn't have this common asset around the world if you didn't have some amount of compatibility and interoperation and some amount of actual innovation, both things like V8 and the other jitting runtimes making it super fast, and the actual work to make the language complete, fill the gaps and make it a better language for people writing code and also for things like Emscript. And so I feel like JavaScript still got a while to go. It's still uptrending and there's still things to fix in it. And it's still generating returns for all the developers who benefit from that shared sort of common good.
That was awesome. That's a lot of good history that I think,
Yep.
I don't know if you know this, but you're kind of a big deal.
yeah.
So, in some ways, I'm like the person who was there at the time and had to do it. It's true that nobody else in Netscape would have done it. I was the language buff and the fast implementer, but, all those mistakes, I'm sure there are people elsewhere in the world who could have done a better job, but they weren't there. Also, maybe they would have insisted on more time, and that would have failed, or maybe if they got the time, it would have been better for it, but I didn't do that either. So it's an accident, but it's I think a happy accident in terms of the developer community. Like a lot of the good ideas and the bug fixes and the optimizations and the extensions, the API extensions especially, came from developers. So I couldn't have done it without the developers.
So I have a couple questions just looking back on where JavaScript has gone since its inception. What are the things that have most surprised you? Like, what are the uses that have most surprised you for JavaScript?
Robots.
25.
Awesome.
I think Node.js was a surprise too. I think Ryan Dahl was looking for, he's kind of a C Unix guy like me, so I think I kind of get him. He was looking for something that was close enough to the Unix system call table and didn't have blocking in it. And JavaScript was it. V8 was it in particular for him. And that's fine. But that was a bit of a surprise. And it shouldn't have been a surprise. Once you have kind of open source as a commodity, as a means for companies to hire people and get better QA, like I think a lot of open source is like that. It isn't necessarily about the community. It's about how can I get my code better tested? How can I recruit talent that I can't find otherwise? It just comes to the open source project. And that's fine too. That's really where a lot of value in open source comes from. V8 has benefited from that, and they benefited Node, and Node has benefited people. I worry that Node is kind of, you've seen people defect to Go lately, and you, like Felix and then TJ, and you realize Node and JavaScript itself are not the last word in like systems architecture or programming languages. So evolution goes on, and there should be other languages, especially where the switching cost is low enough on the server side. There are other languages. People are doing awesome things with new programming languages. And people are building great languages on top of JavaScript on the client side because that's the low switching cost path. Compile to JavaScript. You're not going to easily wedge another VM into browsers in a standard way, or even in any browser like Dart is going to have a hard time getting into Chrome. But Google can do it. But will it pay off? I doubt it. And in the meantime, you can compile to JavaScript. You can co-evolve JavaScript and these new languages like Dart, TypeScript, the sort of Haskell influenced languages that are coming along, like Elm. And there's mutual learning there, and there's co-evolution. That's where I think we can actually accelerate things. Like the web could be so much better than it is if the various participants leaned into it more instead of like being distracted by their own ability to innovate in a proprietary way, essentially a proprietary way, even if there's open source. It's like Yehuda Katz said, every time somebody does something like a Chrome innovation that could only be in Chrome, and it's very hard to standardize, it's a big new code base, and it's kind of a big team at Google. It's like, cool story, bro, but what good is it? I can't target that in iOS Safari. It doesn't mean anything. And meanwhile, iOS Safari is investing in its own things, but also Apple's investing in native iOS widgets and, stuff like LLVM and Swift. But I see some convergence. Like LLVM is this great compiler framework that's used by Emscripten. Emscripten is basically a JavaScript backend for LLVM that allows you to cross-compile C++ apps like Unreal Engine apps or Unity games to JavaScript and WebGL. So we're starting to see convergence through compilers, cross-compilers, and through people working intentionally on the web to fill the gaps and do the extensible web manifesto thing of building up the lowest level possible that's still efficient when you use it at scale, so that you don't have the standards bodies inventing these big sky castle, high-level standards or high-level APIs. That should be done on GitHub. The standards body should be building up from below. And that I believe strongly. And if there was more intentional, coherent, collaborative work that way, or even competitive work that way, I think the web could be even better than it is. And I think it will be.
It's awesome.
Angular or Ember?
Oh, jeez.
Like I said, it would be a disaster. If you imagine W3C trying to pick a winner and standardize it, it would be like they would pick like Dojo right when jQuery was coming out. It would be a mistake. So I don't really have a dog in that fight. I actually like things about Ember that I've seen. I also like things about React, which is in some ways less ambitious because React just says we're the view. You can use us with Ember or Angular, right? So people are starting to realize that MVC, the C is kind of vestigial, the controller is kind of vestigial, and the view, there are various ways to skin that cat, and I like the React way of using, virtual DOM diffing and immutability, and the work Rich Hickey did with Clojure, which has borne fruit in many areas, based on lots of prior art about immutability, solving the sort of time versus state problem. That's really appealing to me. Swan Odette, if you guys
David Nolan
has done some good work in JavaScript and in the compile to JavaScript version of Clojure script. So I think all that stuff is too early to standardize. Some of it looks very promising. It needs to be pursued. It needs to be adopted and then battle tested, and then we can standardize the pieces that deserve to be standardized and make things super fast.
That's a very intelligent answer to a kind of a silly question that I sort of asked as a joke.
Yeah.
But I love that answer. That's great. I do want to ask you specifically, what do you think of what Angular does with, customizing HTML, writing your own HTML?
So I actually like that. I like also, believe it or not, this is a kind of a blast from the past with respect to E4X. I like the JSX syntax that React has. I think it turns out Sweet.js, which is a macros for JavaScript project started at Mozilla Research when I was at Mozilla, can do that. It can do JSX at least. I'm not sure about the Angular extensions. But everything in HTML and JavaScript should be ultimately taken out of the committee's hands, the standards bodies, like TC39 or the WhatWG or the HTML group. It should be in the developer's hands, which means things like hygienic macros and extensible custom elements. And so I'm in favor of that in principle. And custom elements, among the many things in web components, which Google, I think what Mozilla is spearheading, that looks pretty promising and should be doable. In fact, you can do it, like Sam Ruby demonstrated this years ago. You can make, HTML lets you make up unknown tags, right? And they turn into elements in the DOM that just don't have any particular magic to them. And then you can go into them and inspect them and rewrite them. So Sam had a demo where he loaded MathML as HTML, and it made a bunch of unknown elements, but then he went through with a sort of a tree walker that recognized that these were MathML elements and made them render MathML. You can do that with like SVG. We want custom elements. We want, ultimately, I hope, at least offline, if not online, hygienic macros. And then JavaScript is done, right? At that point, you fill all the semantic gaps. You have typed arrays, typed objects. You have probably lots of ways of controlling memory allocation in a precise way that doesn't run into garbage collector faults or performance problems. You probably have all the affordances and classes that you want in more concise functions. I think you've got all the statements and expressions you could ever want. We'll have, thanks to Rick Waldron, the exponentiation operator, ***. I mean, how many more do you need? At some point, Sweet.js ties the knot and people can write hygienic macros and extend the language. They can even do JSX. They can do like markup, angle bracket, delimited markup. And then it's not quite the promised land, but it's pretty close. It puts all the power in the developer's hands. It lets people, the complaint is then macros allow you to do things like in Lisp, common Lisp or Scheme, where you have basically dialects that different adherents cannot understand. They're mutually incomprehensible because they don't understand each other's macrology, but they should just learn. It's all based on a common set of primitives. And that's the important thing. You can reason about the primitives. You can compose them. They're compositional. They compose orthogonally. That's the goal here. JavaScript has a lot of warts in it, but if you weed those out or deprecate them, you end up with stuff that is compositional. And that's where I think we're heading.
Awesome.
So it's interesting that you're talking about all of these different capabilities. I've noticed that, the more recent, larger JavaScript applications, they really do feel more like applications and less like web pages or websites. Mm-hmm. Does that make sense?
Yeah.
Is that the direction we're going here with this, or?
It is. So originally the vision was JavaScript will be the glue language, like the stupid little brother sidekick to Java, and you write all your components in Java and you glue them together. Maybe you, being a different programmer, a less experienced programmer, would take the components invented by the high-priced experienced programmer and glue them together with HTML and images and CSS to make an app. And that is still done, and that will continue to be done. But you're also seeing, SPAs and people building, whether they're using JSX or some consolidated syntax, they're building applications that are very large. And JavaScript as a scripting language, or as a language that was easy to use, JavaScript wasn't meant to scale up to, hundreds of thousands of lines. So even things that Mozilla research, like the Shumway project, which is a Flash player in JavaScript, which is pretty awesome, have started using TypeScript because you want that kind of ahead of time warning system. You want warn script. You want modules before they're actually implemented fully in SpiderMonkey. You can get the benefit of them from using TypeScript. So I do see, building large applications requires different tools and different affordances in the language. It involves social problem solving among a larger team that isn't just about the expressiveness of the language or whether it's, complete by some measure. It involves whether you can actually understand the other guy's code or write tests for the other person's code, or can you actually work together at scale? And that's also coming. Again, TypeScript is smart because it's kind of embracing and extending. Let's hope Microsoft doesn't try to extinguish. That's the third. I don't think they will. I think they actually bought into JavaScript at some level. And I've talked to people like Anders Helsberg about this. And they also, coming with little mobile market share compared to iOS and Android, I think they have incentives to work on JavaScript as a platform language instead of trying to start over.
Well, they almost killed it with Iron Ruby, right?
The whole thing where they were doing like Silverlight and multiple languages and a sort of a .NET Lite, it didn't work out. That was kind of the same era as the Flash Xamarin ActionScript era. Right. The web endures. And yet, you have Zuckerberg 2 years ago saying the web was a big mistake for us for 2 years. We wasted a lot of money on it. But he buried his own lead. In that same paragraph, he said the web's still pretty important. I'm pretty optimistic. And it's still bigger for us in the M site than some of all our native apps at that time. Now, they've gone on to have, better native apps, but their native apps aren't even fully native. You look at the Facebook iOS app, it has a lot of web views in it. So clearly the web's important. You look at the Amazon app on iOS, it's got a native home screen, of course. But once you get into the catalog, the marketplace, it's web. It has to be because Amazon has this incredible information architecture that they already mapped to HTML in very detailed ways, like the cross-through price with the cheaper price or the Kindle price. There's no way you're going to pay somebody to recreate all that presentation in Cocoa Touch. It's just insane. You wouldn't do it. You get it wrong.
To me, it seems like a lot of this native stuff is a step backwards. And I hear a lot of people saying that the prediction is that the web is going to bow down to native. But it's like, well, then there's so many different native frameworks. To me, it seems like their time would be better spent in optimizing the browser on that mobile device than coming out with Swift, for example. What are your thoughts on that?
So there's a tension. Obviously, that's true because Apple did the web a solid or two in WWDC in June. They announced WebGL support enabled in iOS 8, which had been turned off. That's like the last WebGL domino to fall after IE 11 shipped WebGL support. They announced full 4-tier optimizing JavaScript core JIT support for apps. That even helps Chrome for iOS. But Apple, I think, can't afford to sandbag the web. They have to worry about Google flanking them by taking over the web. So Apple's still in there uplifting the web, even though they're also uplifting the native side. And like I mentioned, Swift, if you read Chris Latner's blog, not the public Apple's propaganda, but Chris actually gave Rust at Mozilla Research credit for influencing Swift. And he said Swift started as his own personal project in 2010. So I believe that. And Swift's just a better, language than Objective-C by far. And it's an LLVM front-end language. So the real asset there is the open source LLVM compiler framework for ahead-of-time compilation. And again, that benefits not just Swift, but Emscripten. It benefits Epic Games and Unity, Unreal Engine and the Unity engine. It benefits everybody else doing cross-compilation to the web. And it's no secret it's being used at places like Autodesk, and I think Adobe's looking at it. So Emscripten is a big deal. Compile to JavaScript is a big deal. Mapping C++, quote, native code to JavaScript, that's happening. Even Google's portable native client folks will reference Emscripten as, oh yeah, if you use Pinnacle, it only works in Chrome, but to work in other browsers, you run a separate Emscripten pass, you get JavaScript out, you can run that in other browsers. So there's clearly, the web is not dead, far from it. It's in everyone's interest who's not dominating the web to uplift it. That's where Apple and Microsoft are cooperating in spite of their native frameworks. And even Google has a lot of solid web people, but they also have their native stack, and maybe they have too many engineers. I don't know. They seem to sometimes conflict with each other more than anybody else when I see them fight in standards bodies. But I think the web is too great an asset. The number of web developers, like estimated, this is rough, like 8 million or more now, far more than iOS and Android developers. So you see companies like Colin Jackson, a friend who was at Stanford under John Mitchell. He and Adam Barth were doing like browser security back in the day when hardly any other academic CS researchers were looking at browsers. Colin has a company called App Portable, which is cross-compiling iOS, Cocoa 2D, Cocoa Touch apps, mostly games, to Android. Because a lot of those games get developed for iOS first, because that's where the high monetization user is. And then when you get to Android, which is the big volume OS, you don't want to rewrite it by hand. Just press a button, App Portable generates the code. So I think that's awesome. I think compilers and the web are like a perfect marriage for keeping up with native. And if the web just gets those gaps filled, obviously, I'm not going to lie to you guys, like WebGL is based on OpenGL ES2. It should be ES3. It should be WebGL, should be based on OpenGL 4, the desktop version, if the desktop GPU is there. Because we're all used to sorting through old browsers and downright hardware and small screens and non-retina screens. Why can't we have, the best of the GPUs instead of the lowest common denominator? And I think anybody working on the web, and this is a problem with Mozilla too, frankly, who thinks of the web as only the lowest common denominator is doing it wrong. You want the web to be the best of the native. You want to compete.
So why aren't we hearing more about ASM lately?
I'm not at Mozilla, but I think they're still plugging away. The Unreal Engine 4 is coming up in it. There's work, I don't want to get ahead of myself here, but there's work even with Googlers on exposing all the missing low-level APIs that are needed for native code, like threads, frankly. SIMD is public. This is in the ECMA TC39 meeting notes that you'll see on esdiscuss.org. Like John McCutcheon, who's an ex-gamer developer who went to Google and worked on Dart's SIMD intrinsics, like single instruction, multiple data, short vector instructions, like for the SSE unit on Intel and the Neon unit on ARM. This is a way of parallelizing by 4x using parallel data operations on short vectors, like 4 32-bit floating point numbers at a time. That's great for gamers and DSP hackers and lots of people, crypto hackers. John did a nice job on Dart, and he tweeted about it, and I tweeted back, and I said, hey, how about let's put this in JavaScript so you can actually make Dart.js compile to something that works instead of having it be really slow. And he said, okay, and he's joined the ECMA group, and Intel and Mozilla and Google have thus collaborated on SIMD for ES7, which is implementing in SpiderMonkey and V8, thanks to Intel folks. So there's a lot of stuff that people think, JavaScript can't do X, can't do definite types. Well, it can through typed arrays. Can't do no garbage collection allocation. Again, through typed arrays, through Emscripten. Can't do SIMD. That's coming. Can't do threads. Even threads are coming. The trick is to avoid or somehow manage the risk of data races. But all that stuff can happen. And at that point, JavaScript is almost this complete target language for C or C++. And at that point, I think you will see lots of games. Even now, you'll see Unreal Engine 3 licensees like the Monster Madness folks have released on the web. Unity has said that the web is a first-class target for them. Epic, with Unreal Engine 4, has the web as a first-class target. And this means not just Firefox, but Chrome, and it definitely means IE. I can't say more, but like the Channel 9 video from last year with Anders Helsberg and Steve Luco and Luke Hoban and Microsoft all talking about ASM, you can tell they're interested, and it makes sense. They don't want to be left behind. They want to make the Chakra engine in IE 12 or 13 run compiled native code, C++ to JavaScript super fast. They've done WebGL. They swallowed that. It was so funny. Microsoft said, Direct 9, Direct 11, Direct whatever, we're not going to do WebGL. No, yes. And then they said, it's like down the memory hole. Suddenly WebGL's in IE11. It's like all is forgiven. It's WebGL. So WebGL being turned on in iOS 8, I think at that point, the game plan is to have WebGL 2 based on OpenGL 3. WebGL 3 should add other things like ARB compute shader, general computing on the GPU. JavaScript will be the shortest path to massive parallel computing power. And it'll allow you to take legacy code bases. And legacy doesn't mean old, boring. It means like hot games that can only be written in C++, because that's the way to get them to the metal on an Xbox, and cross-compile them to the web.
So I also I wonder a little bit, does your role with JavaScript change now that you're not with Mozilla anymore?
So I'm on the TC39 standards body still, and I think that'll continue. ACMA wants me to remain, and they were kind enough to give me an award last time, along with Waldemar Horwath, because I think they recognize people who've been doing this for a long time. And so Waldemar and myself, even longer than Waldemar, have been plugging away on JavaScript standards for like 18 years in my case. And so I'm going to continue with TC39, and I'm still very interested in the web. I don't know where I'll end up or what I'll be doing, but I think trying to do something really new, people can say, oh, the Internet of Things requires, mostly powered off devices and very lightweight protocols and very simple processors. And that's true. And that's not JavaScript or HTML. It's going to be much simpler. On the other hand, that's kind of a far out bet. I think the nearer term thing is people experimenting with Arduinos and other such systems, or people doing things like their own Nest-like things, but not locked down or tied into Google's mothership. I'm much more confident in that sort of hobbyist early adopter path. That's what the personal computers, right, in the 70s with the Apple and Apple II and the S100 bus processor sort of computers people built, personal computers, before the IBM PC. All that stuff was incredibly generative in its day. And obviously the biggest success there was Apple, still with us. But I don't think Internet of Things is going to be a clean break from the Internet. I think there has to be continuity and evolution. And if we end up finding a path that miniaturizes parts of the web to fit on very small sensors or networks that are mostly powered off, I wouldn't be surprised. But I think the web, with all its developers, like 10 million developers, however many it is, that's just too much to just press the reset button on. So I'm still pretty committed to the web.
Awesome. That's probably a good note to wrap up on, don't you think?
Yep.
Yeah, probably.
This has been fantastic.
Yeah, absolutely.
Huzzah!
Epic.
Thanks for coming, Brendan.
Look at the time.
All right, well, should we go ahead and do some picks?
Hi, this is Charles Max Wood, and I've been asked more times than I can count, how do I stay current? There's a lot to this question, and I'm working on a solution. Code badges. That's right. You heard me right. Basically, the idea is that you come and do a code badge, and that gets you an introduction to a topic. Then you can decide if you want to pursue it further. But while working on the badge, you gain enough proficiency to be able to pick it up again if you need. A lot of technology comes through on the bleeding edge, and not all of it sticks, but the principles do. So doing badges on the technologies that will get you ahead will provide you with experience needed to stay competitive. Plus, it offers social proof that you know something about the topic. The project is on Kickstarter right now. You can support it and get on the launch list at codebadge.org.
All right, Aaron, do you want to start us the picks?
Yeah, I got 3 picks this week. The first one is, I tried it out just to see what, but it's called Happy.js, and it's Walmart's version of Express. I hate to say it like that. Walmart guys probably are like, screw you, man, but it's Walmart's framework on top of Node to do REST API, and I thought it was awesome. I really liked it.
Yeah, you normally don't want to call something the Walmart version of anything, right? That's not a selling point.
Yeah, no. I meant, yeah. So it's a really, really good framework. If anyone's looking, maybe check it out. The next pick, I'm picking it because it was bad, but I think everyone should read it. It was called JavaScript Disabled, Should I Care? It was by Valhalla, and I'll put the link in the show notes. But it just wasn't good. Like, I found myself cringing as he would like point out the obvious comebacks and then kind of be like, but I don't really care because here's what I think. And so it was painful, but I think everyone should read it. Any JavaScript developer should check it out. It's called JavaScript Disabled, Should I Care? And the last pick is self-serving. I'm doing a front-end master's course next month. It's in Minnesota. You can listen live from home, but it's on ES6, so I won't do it nearly as much justice as Brendan would, but Rick Waldron is going to go over most of the content to make sure that I'm not telling too many lies and that it looks good. So, but it's going to be a great course. It'll be really, really good. So, front-end masters next month. Those are my picks.
Awesome. AJ, what are your picks?
First of all, I'm going to pick that just perfect moment when Brendan said, cool story, bro, talking about Chrome apps. Because that was epic in ways that only the long-term listeners will understand. Because Frosty is on here, and he's always cool story broing people about stuff, and like Chrome apps are his thing.
I loved it. I thought it was awesome.
Oh, that was hilarious. My other pick for today, actually, I'm gonna pick 2 more things. One, I'm gonna pick "Don't Stop Me Now" by Queen. Yes, because I also felt that was very applicable in that moment where you, like, Brendan was just passionate and going, and then, like, Frosty just had to cut him off. He was having a good time. He just had to cut him off. I'm sorry, I'm picking a little much. And then the last thing I'm going to pick is trending.fm. I don't even think it's in public beta yet, but I know these guys that are in this incubator and they're working on trending.fm, and it's this cool music site where you can tune in and you basically create a group radio station kind of thing. One guy is the DJ, and then everybody else can, like, throw song suggestions in the chat window, and the DJ guy can click, add. And so great for, like, the office type scenario or something like that, or if you just somebody who's really into music, you love their style, and you just want to listen to what they listen to all day.
All right, Jamison, what are your picks?
Oh man, I have more music. This is a music themed episode, or music themed picks at least. One of them is a soundtrack for a little arena shooter game. The game is pretty sweet too, but the soundtrack is my real pick. It's called We Are Doomed, and it's just really good, kind of synthy electronic music. It was kind of my programming soundtrack for the past week. My other pick is another video game soundtrack. There's this PlayStation 3 game that just came out called Hohokum, I think. It's one of those weird artsy games that makes you feel superior for playing it, even though it's not very much fun. But the soundtrack is another fantastic piece of music. It's not as synthy, but I don't know. They're both good listens for programming. Those are my picks.
Awesome. Joe, what are your picks?
All right, so I better stick with the music theme and pick some music. I'm going to try to be a little less pedantic than the rest of you, though. I'm going to pick Nashville Outlaws, a tribute to Motley Crue. New album that I'm not sure when it came out. It came out in the last year. I just noticed it. It has got a whole bunch of country artists singing the hits from Motley Crue. And I absolutely love it because I was a huge Motley Crue fan back in the day. And so hearing it done by these country artists with, totally different type of sound to it, but still the songs that I know and love, absolutely love listening to it. Not really great to program to because you just want to sing, but still a great album. So I'll pick that. And then my second and final pick is going to be Audible. I was recently using audiobooks.com, bought some audiobooks. It was nice because they were $12 every time I wanted to buy an additional one, and didn't have any kind of screwy plans the way that Audible does, but their app completely blows. And after I got the Audible app, I was like, okay, I'm never listening and using the other audible.com app again until they improve it. So I'm also, I guess, in essence, also calling audiobooks.com out on the floor, saying make your app better, because the Audible app really rocks. And this could be my second and final pick.
All right. I just have one pick. I've been working on some subscription stuff. I should have it out here within the next few weeks. Anyway, what I've been using to collect payments is Stripe, and I love Stripe. It is really nice to integrate with, does subscriptions and one-off payments. And I actually have it set up right now at devchat.tv.donate. But anyway, it's just really easy to put together and integrate with. And they have libraries for frickin' every language. So go check them out, stripe.com. Brendan, what are your picks?
Oh, Guardians of the Galaxy.
I love that movie.
Which hero are you?
I am Groot.
I was hoping you said that, bro.
Is that all of them, or?
Yeah, I'm not nearly as hip as you guys. I'm old school. I still use like Vim in a terminal.
I use Emacs in a terminal. We can fight later.
I used Emacs in 1979 and 80 on DEC mini computers. It was Richard Stallman's Emacs. It didn't have eLisp. It had Tico, this crazy stack language. It was you should look it up. It's I switched to Vim and I can't go back. I can do both. I can do Emacs if I have to.
Yeah, that's pretty much what I say about Vim. So
it's true. Typing your name in Vim is very destructive, whereas in Emacs it's constructive.
Yep. All right. Well, thanks for coming on the show. We really appreciate you taking the time.
Yeah, this was incredible. I'm really glad I got to hear the history lessons.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.